Okay, so let's go ahead and look over the quiz that you just took. You're going to have a test coming up on Friday. I'm not sure how many times you went back and rewatched the video over the notes. That would probably be helpful. Making sure you go back and have the right answers on your homework would be helpful. Watching this and going back and practicing the questions will be helpful. But you have a test on Friday, so be prepared and be ready for that test that you've got. Let's look at the first one. It says here, there is a free-falling trajectory of an object that's thrown horizontally from the top of a building as shown above in the dashed figured line. Okay, so it's coming down this direction. It says, which set of arrows best corresponds with the direction of the horizontal velocity and the acceleration? So if this object was thrown out, does it have a horizontal velocity? Yes, it does. In this direction. Does it have an acceleration? Absolutely. A downward direction. Acceleration is down. Horizontal velocity, x v sub x, would be in this direction. Which two arrows corresponds with that? Only answer that we can have is B. B is the correct answer. Let's keep going. There's a skateboarder here who gets a rolling start along a level sidewalk and then jumps off, lands, and continues to roll on. The time that the skater is on the air between the rolling off the upper cliff or upper level and touching down to the lower level is it going to increase? Is the time going to increase if the skater gets a faster rolling start? If he was to go back again and get a faster rolling start here, would the time increase? Would the time decrease if the drop of is a longer distance? Would it be unchanged if the skater gets a faster rolling start? Would it decrease if the skater gets a faster rolling start? First thing is, if the skater is going to go back again to the top and he's going to jump from here to here as a distance off of this ledge down here, I don't care how fast he moves horizontally, that has no significance to the amount of time it's going to take for him to fall down and hit this sidewalk. Why? Because the distance is the same. He can go as fast as he wants here or as slow as he wants. It does not matter. The distance is the same. So it is going to be unchanged amount of time if he gets a faster rolling start. He will be in the air for the same amount of time. Let's continue to move on. Says here that a motorcycle is driven up a hill with a 22-degree incline. The motorcycle has a constant speed of 18 meters per second. What are the horizontal components of the motorcycle's velocity? The motorcycle is driving up a hill at a 22-degree incline. Oops. There we go. Now, they gave me constant speed of 18 meters per second. What are the horizontal component of the motorcycle's velocity? Here is horizontal components. So what do I see? I see if I draw a line this way, it forms a right angle. If I draw the arrow to the opposite, that's my hypotenuse. Here's my theta and my right angle, which is my adjacent leg. What's left over is my opposite. I'm going to grab my highlighter and say, look at this. They gave me my hypotenuse leg. I question marked over here, this side, which is my adjacent leg. I need to toa this. What am I going to look for? A and H, which is the cosine. A and H. So the cosine of the theta equals A over H. Okay. So the cosine of 22 degrees is A over 18. I need to get A by itself. So we multiply by 18 on this side. That cancels. Multiply by 18 on this side. Let me grab my calculator out. Please make sure you are in degrees and not in radians. The cosine of 22 degrees. Oops. Cosine of 22 degrees equals, multiply by 18. 16.69 meters per second is the correct answer. Let's keep going. An arrow is shot horizontally and travels 200 meters. The bow is 1.9 meters above the ground. What speed must the arrow have been traveling? All right. All right, we got an arrow. It's going to go. The distance 1.9 meters above the ground. It travels horizontally a distance of 200 meters. What speed, question mark, velocity I'm looking for? First step is to draw it out. Second step is my x and y component. dTV, dTVIA, and VF. The distance horizontally is 200. The time was not given. The velocity is my unknown. The distance vertically is 1.9. The time was not given. The velocity is 0. The acceleration is 9.81. And final velocity was not given. I'm going to grab my highlighter. And I'm looking to see that I'm looking for the x component equation. Do I have enough information? No, I do not. So I'm going to come over here to the y component, solve for the t first, and then plug that into the x. So it's a two-step problem. Step 1, d equals 1/2 at squared, or 1.9 equals 0.5 times 9.81 times t squared. Divide by 4.905. That cancels. Divide by 4.905. 1.9 divided by 4.905 comes out to 0.3874. Not my answer. I need to do the opposite of the square, which is a square root. So let's square root that of 0.3874. T comes out to 0.6224. That is only my seconds or my time. So 0.6224, 0.6224. Now let's go ahead and use our x component equation, which is d equals v times t. D is 200 equals v times 0.6224. Divide by 0.6224. That cancels. Divide by 0.6224. 200 divided by 0.6224 comes out to 321.34 meters per second. Okay. Let's keep going. Next one here is a rescue pilot drives a survival kit while her airplane is traveling at an altitude of 2,000 meters with a forward velocity of 100 meters per second. If we are going to neglect and disregard air friction, how far in advance of the starving explorer's drop zone should she release the package? You must include the SI units. Step 1, do your drawing. So there it is. My airplane has a forward velocity of 100 meters. They are going to drop a package. We know that the altitude up is 2,000 meters. We need to know how far out. The question is from here to here, what is that horizontal distance? Did my drawing? Let's do step 2, which my x and my y component. DTV, DTVI, AVF. The distance horizontally is what I'm looking for. The time was never given. The velocity of 100. The distance is 2,000. T was not given. VI is 0. A is 9.81. And VF was not given. Get my highlighter. What side? I'm looking for the X component side. Great. Can I solve for it? No. I need to go to the Y component first. Solve for the T. Plug it in over here. This is going to be a 2-step problem. Step 1. D equals 1/2 AT squared. Or 2,000 equals 0.5 times 9.81 times T squared. Divide by 4.905. Divide by 4.905. That cancels. So 2,000 divided by 4.905 comes out to 40.775. That's not my answer. I'm going to square root that. So second square root of 40.775 equals 6.39 seconds. Not my answer. Okay. So 6.39, 6.39. Now I have enough information so I can solve for that distance. So part 2, D equals V times T, or D equals 100 times 6.39. So 100 times 6.39 comes up to a distance of 639 meters. Before you hit that drop zone is where you need to release the package so that way it will fall right on the correct spot. Okay, that's my answer. Let's move on. It says here, which of the following statements are true of the motion or of the vertical motion of projectiles? Okay. The vertical component of projectile velocity is constant. Value? No. The vertical component of a projectile's velocity is constant? No. Homework number 4 showed you that it wasn't constant. The vertical component of a projectile's velocity is constant? No. Whether it's a constant value of 9.81? No. Is it a constant value at all? No, it's not. It changes. The vertical component of a projectile's velocity is changing. Oh, yes, I just said that. Changing. I like that. Let's keep going, though. A projectile with an upward component of motion will have an upward component of acceleration? No, not at all. A vertical acceleration of a projectile is 0 meters per second squared when that's at the peak? No, absolutely not. The velocity is 0, but not acceleration. As a projectile rises towards the peak of its trajectory, the vertical acceleration will decrease? No. Acceleration is going to remain the same. So far, this is the only one that is correct. Let's keep going. Next one here says, which of the following statement is false? Oh, okay, we're looking for false. Of a vertical motion of the projectile. Okay. A vertical component of a projectile's velocity is changing. That is true. A projectile with a downward component of motion will have a downward component of acceleration, yes. The peak height at which the projectile rises above the launch location is dependent upon the initial velocity, vertical velocity. Yeah. It's going to get there, but it depends on how fast it is. Why? Because of the vector quantities that are opposite, right? Acceleration is pulling down and the velocity is in upward direction. They eventually are going to subtract to zero, depending on this, because this downward is going to be a constant at negative 9.81. And a projectile with an upward component of motion will have an upward component of acceleration. False. That is my false statement. Next one, look at this diagram over here below. Go ahead and type the magnitude with the SI unit and direction. Well, both of these vectors are in opposite direction, so opposites equals to subtract them. So 75 take away 70 equals 5. So my answer is 5. What's the SI unit? A capital N for Newton. What direction? Who is bigger, 75 or 70? 75. What direction? To the right. I think somebody put east, and that works as well. Next one. Let's go ahead and let's work this out, but I didn't get enough space here. So I didn't give myself enough space. Let me go ahead and, here we go. So now I can work it out. An astronaut stands on the edge of a lunar crater on the moon and throws a half-eaten Twinkie horizontally with a velocity of 5 meters per second. The floor of the crater is 100 meters below the astronaut. What horizontal distance will the Twinkie travel before hitting the crater? So, first key thing here is they use the word astronaut and they use the word lunar crater. There are a couple of things in physics that we can assume. One of them is that we can assume that we are always on Earth. But when they use the word astronaut and lunar crater, automatically I'm not on Earth. I'm on the moon. So what do I need to do first? I need to first figure out what is the gravity of the moon. Well, if the gravity on Earth is 9.81, and I know from my notes, and you know what? I have my notes right here also, that the moon is 1/6 of the size of Earth, meaning that the gravity is 6 times smaller. If I divide this by 6, I can find out that 9.81 divided by 6 comes out to 1.635 meters per second square. This is the acceleration of gravity on the moon. That was actually my step number 1 first before I do anything. Now I'm going to go ahead and do my drawing. I'm going to get my astronaut. He's got his big old spacesuit on. He's got a Twinkie. He's going to toss it into this crater. Now I do know that the crater height, the floor of the crater, is 100 meters below. And I know that the astronaut tossed it with a velocity of 5 meters per second. I'm looking for how far here horizontal. So I did my drawing. This is step 2. Step number 3 is to do my X and my Y component. DTV, DTVIAMVF. The distance is my unknown. The T was not given to me. The V was 5. The distance is 100. The T was not given. The VI is 0. The A is not negative 9.81. It's actually a negative 1.635. And the final velocity was not given. Now I'm going to use my highlighter. What side am I looking for? I'm looking for the X component. Could I solve for it? No, I cannot. Go to the y component, find the t, plug it in, and then I can solve for it. So it is a two-step problem. So let's go ahead and come over here to step number 4. On step 4, I'm going to d equals 1/2 at squared, or 100 equals 0.5 times 1.635 times t squared. I'm going to get 1.635 multiplied by 0.5. That comes out to 0.8175. Cancel 0.8175. So 100 divided by 0.8175 equals that's not my answer. I need to square root this. T equals 11.06 seconds. So 11.06, 11.06. Now let's do the next step. D equals V times T, or D equals 5 times 11.06. Which should come up to about 55.3 meters. I will take a picture of this so that way you'll have that as well. Let's go to the next question. A rock has a mass of m and is thrown off of a building with a height of h. It says here that the speed of the rock as it leaves the thrower's hand off the edge of the building is v sub 0. How much time does it take for the rock to travel from the ledge to down to the building? If I'm going from the building person has a rock, they're going to throw it down. I'm looking for question mark, how much time does it take? Am I looking for horizontal or vertical? They're throwing it down. Hopefully you see that this is a vertical. If it's a vertical component, what is my equation for vertical components? D equals 1/2 at squared. Well, what are some other ways that I can write this? They told me that the D was actually the H as height. And they told me about the mass. Did I care about the mass? No, that was extra junk. Do I care about the velocity? Only if I was looking for the horizontal component. But honestly, that's not needed for vertical. So what they did was they just used different variables. It's the same exact equation that you have done before. So instead of a D, they used H for height. They wrote 1/2 this way. Instead of A, they used G for gravity, T squared. Now let's go ahead and isolate for T by itself. Remember, not T squared, but T. What would be the first step if you have an equation mathematically like this, algebra-wise? Wouldn't you multiply this side by 2 to cancel out that 2 at the bottom? That means that you multiply this side by 2. Now we still got to get T by itself. Wouldn't you divide this side by G to cancel? Divide this side by G. But I still have the T squared. Wouldn't you square root this? So wouldn't T equals the square root of 2H over G? Look at that. You have been doing this equation this whole time. It's just that you've been doing it with a little differently. Okay? They did this all in one shot, one step. We do ours by step, by step, by step. What is the acceleration on Mars if the planet is 2.6 times smaller than Earth? Well, Earth is negative 9.81. And Mars is 2.6 times smaller. going to divide by 2.6. 3.77 meters per second square. Okay, and that's how I found that answer. If you gave me a negative, you're awesome. Awesome. Let's keep going. Says here that while flying due east 130 kilometers per hour, an airplane is also carried north. So east 130 kilometers per hour. It's also carried north 50 kilometers per hour by the wind. Find the angle of the resultant velocity of this airplane. What is this theta? Well, I see that I have a right angle here. If I draw my arrow, this is my hypotenuse. Here's my theta, and there's my right angle, which is my adjacent and my opposite. I need to ka, toa. I'm going to highlight this leg and this leg. My A and my O. Who is A and O? My tan. So the tan of the theta equals the O over the A. Or the tan of the theta equals 50 divided by 130. 50 divided by 130, I get is 0.385. That is not my answer. Just like square and square root, we have to do the opposite. We have to find the inverse. Second key tan, 0.385 equals 21.06 degrees. Next one. The horizontal motion of a projectile is independent of the vertical motion. True. Next part here. A person is flying a kite, releases a string of 176 meters. $176. The string makes an angle of 27 degrees to the ground. How high is this kite? Well, I see that I have a right triangle, and if I go here to the opposite side of the right angle, then this is my hypotenuse. My theta and right angle is my adjacent side, and that's my opposite. I'm looking for the O side, or this leg, and they gave me the H, the hypotenuse. So, toa. Toa. Who do I have? My O and H. Who is O and H? The So. So the sine of the theta equals the opposite over the hypotenuse. Or the sine of 27 degrees equals the O over 176. Let's use our algebra. Multiply by 176 to cancel. Multiply by 176. So the sine of 27 degrees, multiply it by 176, equals 70.9 meters up. And let's look, then we're at the last question. It says here that there's a ball and it's going to land on A, B, and C. So there's 3 different trajectories that are going to happen. Now, if they leave at different, speeds, which one's going to land first? Location A, B, or C? But wait a minute. It's going to land from the same table, from the same height. I don't care how fast they're shooting off of this table, okay, or how slow it's going to roll. it does not matter on who is going to land first. The answer is none, because all the trajectories are going to hit the ground at the same time, okay, because they're leaving from the same height. Alrighty, so there goes all the answers, and you should also have the pictures as well. Hopefully that helps.